might say that if you are involved with fluid dynamics, it's all about airflow and aerodynamics. However, bear in mind that fluid dynamics is a subdiscipline of fluid mechanics, and it describes the flow of fluids, where fluids can mean liquids or gases, such as air. And normally it has two subdisciplines, aerodynamics as well as hydrodynamics. Now, when your interest is in the flow of gases and liquids, and specifically if you're into the hydrodynamics, you might be very interested in floods and flash floods, and you want to explain and study flash floods and even predict them. And what I've got here for you is just a short demonstration of studies that were made with floods and flash floods, and look how many times mathematical words are being used in these essays and in these research pieces. Computations, mathematical model, equations, solve these equations, estimate, calculated, calculation. Then we've got mathematical model, mathematical models, analyzing the non-linear dynamics. Now, these may or may not have anything to do with the specific mathematics. You might argue that most of these models are computer models. Somebody else has already figured out the mathematics behind it, as you can see there, those equations, and you just need to feed in the various variables and parameters, which is a fair argument. However, bear in mind how many times you have to describe and how many times you have to think mathematically, even in something as diverse from algebra and trigonometry as flash floods. So just bear that in mind. Mathematics is important at school level because it teaches you how to think, and you become a better professional after school because of mathematics, not necessarily because of the algebra and the equations that you can or cannot solve.